Hello, welcome to problem solving session for NPTEL course Problem Solving Through Programming in C. This is week 11, and first we have a couple of problems which are multiple choice questions, and then we will have few programming questions. So problem number one, most of the problems in this are of the same time. That is that you have to find the output of the program. So here we have a simple program which has three variables I, j, and a var variable which is initialized to character a. Then we have this two nested for loops, where first for loop is starting from I equal to 5, and second one is initialized from j equal to 0. And inside the nested for loops, we have one print statement which is printing the value of variable var plus j, and it is printing it as a character. So you have to tell that what will be the output of this program.
It will be like A, B, C, D, E, A, B, C, D, A, B, C, A, B, A.
Yeah, that's correct. Yeah. So this is what you said. So the inner loop iterates for value less than equal to ai, and thus it will print a, b, c, d, e, then one less every time. That's right. So next question is, what is the output of this program? Here we have a counter integer variable initialized to 1. Then we have a do while loop inside which we have a one printf printing the value of counter. Then counter is incremented. Then the while loop condition is counter is greater than 10, equal to 10. And then we have another print. And so what is the output of this program?
Eleven.
It will print 11.
Yeah.
Can you tell me how? Can you explain?
So first it will print all the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
And then at last, when while loop does not, even when the while loop does not satisfy the condition, it will go to do first.
Yeah.
So see, when counter is equal to 10, then we'll go to while loop. While loop condition is satisfied, then it will do, after that it will increment once. Then the while loop is not satisfied because counter equals to 11. So the last value of the counter after the loop will be 11.
Okay. So what is the value of, so here the condition, what is the condition? Condition is counter is greater than equal to 10.
Yeah.
But counter is initially 1. Can you please mute yourself? Not you, Neha. Someone else joined. Okay. Yeah, so here counter is 1 initially. Then do, you will go inside do, you'll print the value of counter which is 1. You increment it by 1, it becomes 2. Then condition is while counter is greater than equal to 10 and counter is 2. 2 is greater than equal to 10 will be false.
Okay, I got confused. I thought it was less than simple.
Yeah, got confused. Yeah. So it will be false, and so then it will come out and print after loop counter is, what should it print now?
2.
Yeah, so then option B, it will be correct. First it will print 1, then it will print after loop counter is equal to 2. Then we have a similar program here. So again, what is the output of this program?
One.
Right. So it will, one second, what will be the output? 1, 1.
Only one, because it's not going into the while loop. So there is only one printf statement now.
Okay, which one?
After the loop, counter is equal to 1.
Right. Yeah, so only this printf statement will be executed. It will not go inside the while loop because the condition here becomes false, so it doesn't go inside. So just this will be printed, and counter is not changed, so counter is still 1. It will print after loop counter equal 1. Okay. So for this program, you have to tell how many times hello is printed.
Ten times.
10 times?
Yes. And 3.
Okay. Why is it 10?
So, so the first printf is, you know, I didn't understand it. While inside the while, there has to be some condition, but here, like printf and loop variable, then loop must be 0 for that's the exit the loop. But
Right.
I didn't understand that pretty thing.
Yeah.
I didn't understand the printf hello. So it's
Okay.
just like loop bar is the condition and will just be printing printf every time. Is that correct?
Okay, so the yeah. So the thing is that printf hello. So this printf function, it returns a value. What does it return? It returns the number of characters printed on the screen as output. Okay, so number of characters here printed is non-zero. It is hello, it is printing hello, which has 5 characters plus there is some space. I'm not sure if space is counted or not, but there is non-zero number of characters here which is being printed. So printf will return here say 5 or 6 value. Now if you write while 5 and loop variable minus minus, then 5 is always true. Okay, so printf, this thing is like, you can say, okay, it is like writing that true, always true. It's going to be always true. So don't, did you understand that? And then and means both of these two statements should be true for the while condition to become true. So when the while loop will break whenever the loop variable minus minus this condition become false. This will become false when loop variable becomes 0, which is initially 10, and on every iteration it is being decremented by 1, and it is a post decrement. So it is first checked, then it is decremented. Can you try now?
So 11 times that.
9? Sorry, how many?
9.
No, no,
11.
Yeah, 11 is correct. Can you explain how?
So first it will first print us hello, that is hash 2 and variable will be 10. After that, next time the variable will be 9, 8, 7, 6, 5, 4, like that 10 times, and then the 1 will be there. First it will be checked. So that is the 11th time it's checking. So for the first decrement, first checking and then decrement, right? The different hello will be printed 11 times.
Yeah, so can you, okay, I think you're right. Can you just tell me what will happen on the last iteration? What is the value of loop variable in the last iteration when it becomes false?
Loop variable at the last will be 1, but then after the fourth decrement it will be 0. So while printing it, it is 1, but first its fourth decrementation, after that it will become 0. So it will print hello. After that, the loop will be wrong. Loop variable is equal to 1 for the last iterations.
Yeah.
After that, it will become 0.
After that, it will become 0. But then that will be 10, not 11. Because
No, it's like first print hello will be printed, and then it is going to check the loop variable condition. No?
Yeah. Okay, I'll write it.
So first print hello for the first time, and then it will print again.
Yeah. 1 second. So this is our while loop, and initially loop variable here is initialized to 10. Okay, so first iteration here, loop variable is equal to 10, and so this will be true, it will print hello. This will be 10 will be checked, so true and 10, it will be true, so it will print hello once, and after this the value of loop variable will be 9. It will be 9 after the iteration, like after the check. At check time it is 10, but after it has checked, because it is a post decrement, so value which is going to be used in condition checking is 10, and value after condition checking, like it is changed to 9. So next time here loop variable is 9, then again true and 9, this will be true, and loop variable will be decremented to 8. So this will happen till loop variable, let's say, becomes 1. So then it will be true and 1 will be checked. It will be entirely, the condition will be true, loop variable will become 0 at this time. So if we count, so it is from 1 till 10. So 10 times so far we have found the condition to be true, and hello has been printed 10 times. Now loop variable is 0. At this time, we are here that loop variable is 0, but we are again going to check the while condition because the last while was true. So we are again continuing checking, right? So print will be true Now it will check against 0 this time, and this will become false. Loop variable will be still changed to say -1, but this time it will be false, and loop will break. But it has printed here hello once more. So totally first 10 times, and then this additional one time when the while loop breaks. So while loop not breaks, like while loop condition becomes false in that time. So total 11 times hello is printed in this big manner. Does that make sense?
Yes. Yes.
Okay. Okay. So we have next question. What is the output of this program? And I think, okay.
It's 10 this time.
Huh?
And 10 times hello will be printed 10 times.
Okay. So actually, the right answer here is that it was a compilation error, because here your condition here 1 plus plus. So 1 is a constant, it's a literal, it's not a variable. So your compiler is going to give an error that it is expecting it to be a value variable, like variable value which it can increment. So this plus plus operator is not applicable on this literal. So that's why this is going to be a compilation error here. But otherwise, if it were not, if we ignore and part, then it will print, then you will also need to have, okay, let's ignore in the same question. For this particular program, the answer is compilation error. But let's assume that this and 1 plus plus is not there. Okay, just remove this first, and the while condition has counter is less than equal to 10. Then what will be the answer?
10 times hello will be printed, sir.
Are you sure? If
Yes.
this and 1 plus plus is not there. So
Yes, because it's less than or equals to 10, no?
yeah, but
So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
yeah, and is is the counter being incremented on every iteration?
Oh, no. Yeah, I can see it correctly.
Yeah, so then what is the answer?
Infinite.
Yeah, so then it's an infinite loop, and infinite many times hello is printed. Okay, moving on to next one. Okay, here we have this program which has integer a, integer b equal 1. We have an array x of 5 integers, 1, 2, 3, 4, 5. We are computing the value of a using this expression 5 times 4 plus x, square brackets minus minus b minus 9 divided by 0. Sorry, 9 divided by b. Then printf the value of a. So you have to tell that what, these are your 4 options, and you have to tell what will be the output.
Normal termination because plus and multiplication that is x. Okay. Yep.
Come again.
Yes.
So, sorry, I couldn't hear you.
Not on termination because it will show an error because b will become 0. Dividing by b, no.
Okay. Right, that's right. Yeah.
First, unary operator will be operated.
Yeah, so first of all, this square bracket operator has highest precedence. So this will be evaluated, inside which we have this in decrement of b. Decrement of b is initially 1, it will become 0. After that, the parenthesis has the next precedence. So then 9 divided by b will be computed, and 9 b is 0. So 9 divided by 0 will be divided by 0 error. It will throw at runtime, and therefore at runtime the program will be terminated as an abnormal termination. So that was correct answer. Now, it is the same program, but the value, so instead of b minus b, we have b plus plus here. Then what will be the output?
Eighteen.
3, 18?
Yeah.
Okay. Can you explain?
So first, unary operator will be executed. So b here b plus plus will still be 1 because it's fourth implementation. So x of 1 minus of 9 divided by 2 because both are integers. 9 by 2 is equals to 4. So 20 plus of x of 1 is 4. It's in an array. X of 1 is equals to 2. So 20 plus 2 minus 4 is equals to 18.
Right. Yeah, that's correct. So this b is initially, sorry. Yeah. B is here 1. Initially, the square bracket has highest precedence. So inside this b plus plus, b is 1. But this is a post increment, as you said. So post increment, so increment will happen later, but first x of b will be used. So x of 1, which is 2, value will be used here. Then b will become 2, which will be used here. 9 divided by 2 will be 4. So 5 into 4 plus 2 minus 4 will give us 18. Okay, so this program is like related to pointer. Here you have an array of characters A, B, C, D with these characters, and then you have PPP, which is a character pointer. Then you are doing some operations on these pointers and from on this pointer, and these are your options. That what will be the output of this program.
Option D.
Option?
Is it option B? Then D.
Okay, yeah, that's correct. Can you explain?
So here pointer of PPP is a pointer and ampersand of A of 0 is equals to A. So pointer variable will be equals to A. And then it's post incremented, so it will become B.
Sorry, can you
Then
explain
plus B
again? Can you explain again from beginning?
pointer address of A is being assigned to the pointer variable.
Yeah, here, right.
Address of A is being assigned to the pointer variable. So
Where is it?
pointer plus me.
Where?
What? Excuse me.
Yeah, where is it pointing? PPP.
Pointing to A.
Here, right?
Pointing to A. Address of A. Yeah.
Okay, okay, right. Next.
Pointing to the address of A. And then here in the next line, it's incremental. That basically means the address of. So it's now it's pointing to address of B because it's incremented. This one.
Yeah.
And
Right.
it is in array. Okay. And then here in the next line, now it's first the PP thing. This I kind of guessed it because I didn't understand it properly.
Okay.
Could you explain this?
Okay. Okay, so here first the thing is that this will we this so in printf the associativity of these like is from right to left. I think the right word is associativity, I don't know, but the arguments are actually processed from right to left. Okay, so first of all this is processed, so minus minus star of PPP. So as you said here, PPP points to here B, right? So star of PPP is B, and that minus minus 1 will become A. So A will come. Then, but PPP is not changed. It is still pointing to B, right?
Yeah.
That wasn't changed.
Yeah.
So now here you are incrementing that pointer, okay? Because plus plus is coming before star. So it will now point to C. Plus plus is happening first.
Can you please explain like what the difference? So here in the third last line, before the incrementation, decrementation is being before the pointer, but here it's inside the pointer. So what's the difference between that? So I always get confused.
In this line, so you assume that okay, first like in this case, first star is happening, then minus minus. So it's like you can imagine a parenthesis here, which is like first star will happen, then minus minus will happen. So already when you have,
it's decrementing the address of that.
In this case, it is first dereferencing the pointer. So dereferencing the pointer means now it is a value and it is decrementing the value, not the address. So value at this pointer address, it was B because it was pointing to B. So now you're decrementing that value. Here, you're not changing it in anywhere in the array also. You're just getting that value here. Like imagine there was no minus minus here. Then it was just like star PPP. And if you were printing that, it would have printed B. But now you're saying, okay, minus minus, print that minus minus minus. So it is decrementing the value, which is B. B is decremented once, it becomes A. In this case, however, you have that PPP pointer, which is the address pointing to B. Now when you say plus plus, you're incrementing the address here. So now the pointer is going to point to C. Then you are saying, okay, dereference it. Like what is the value at this address? So the value at this address is now C.
So PPP, the value, the address of A is in the variable PPP. So star is just to dereference those. So star means it just reads the value at the address.
Right. Yeah. Star
You say
is,
star.
yeah, star is the dereference operator. So which is that read the value at this address.
Okay.
Yeah.
Thank you.
Yeah, you're welcome. So is it clear?
Yeah, yeah.
Okay. Okay, so this question we have variable a, which is an integer initialized to 36, and we have a pointer to an integer. So remember that I'm just repeating. I'm sure you would know that pointer uh, has address. Pointer means some address is there in that pointer, and when you are say using star, then you are saying, okay, what is the value at that address? So for example, here it is saying, okay, ptr is equal to address of a. So ptr, say if a was stored at location, say some address 1000, then now ptr will have that 1000 inside it. And I'll just use the whiteboard so that it is easier actually. So with respect to this particular example here, a is 36. It's some variable, okay, which is given here. In memory, like in your program memory, this will be, let's say, it will be some at location. This value is stored in that location, and I'm saying if the address of that location is 1000, some value, so it can be any value, but I'm just assuming here, so let's say it is 1000, then your ptr, which is a pointer to an integer. What does that mean, pointer to an integer? That the address it contains is a address of an integer, okay? And you are here saying, okay, ptr is address of a. What does that mean? Okay, then that means that there is a ptr variable. This is a variable, this is a ptr variable. This variable is also located somewhere, let's say 2001 or some location is there. But what is stored inside this ptr is the address of a, which is
Address of A.
yeah, which is this 1000. Okay, from here. Now when you say that printf %d star ptr, so you're saying print the value at the address stored in ptr. Print the value stored in address, or basically star ptr means the value at address in ptr. So value at address 1000, what is that value? That is this 36. Value at the address in ptr. So this will print you 36 here. Okay, that's it. Like, is any question?
No.
So here ampersand, this ampersand is used to get the address of a variable. Okay, you have the variable a, you're using ampersand. Ampersand is what is the address, that address, like 1000, this 1000 address will be is you can get by using this ampersand operator, and then the star operator is used to get the value at an address. Just remember these two. So this question is,
So with reference to the pointer, will the 1000 be considered as the value of the pointer or the address only? So with reference to the pointer, because it's stored, no, address is stored in the pointer.
yeah, I think that is a bit confusing because if you're so the address of the pointer is actually 2000, because if you consider it like a normal variable,
Yeah.
then it is 2000. If you say address of ptr, that will be 2001 here. If you say ptr, like what is ptr, that is 1000.
Yeah, so 1000 is value.
Yeah, it's a
And
value.
with respect to PTR, it is a value.
Right, it is a value with respect to ptr. But so whenever you so So ampersand PTR is here 2001, PTR here is 1000, and star PTR here is 36.
Okay, perfect.
Okay, so for this question, we just need to know what is ampersand and star operators. So here we have already understood these. So this is like printf, %u, and these two options are there. Star, ampersand PTR, and ampersand star PTR.
Both will print 1000 only, no?
Yeah, both will print 1000.
So
That's
that's
correct.
what I asked. No, so should I think the answer is value and address or address and address? That is what I was asking for.
Yeah, the answer here is address. Both are going to print address of A.
But with respect to here, it will put in the first one, it will print 1000 because it is the value stored in the address of the PTR. Like, because it is value stored in the address of PTR.
Right.
The first one will print 1000 because of that.
Yeah.
So that will be the value and address, no then. Then answer should be B, no?
Oh, you're saying according to that. Mm, address and value. But I think it is. Okay. Yeah, I think then the option should have been a bit more clear in that sense that it is asking with respect to the variable A. Or so, not the pointer.
Because ampersand has an address, but star is always used for dereferencing, as you said, then it must be a value, not the address, right?
Yeah, with respect to PTR, it is a value of that pointer, but with respect to A, it is the address of that variable.
A is address.
Yeah.
Yeah.
So, but the thing is that here, the both of them will print the same value, which is 1000. That is the address of A, and which is in PTR, and that is one way to understand is that ampersand and this the star operator, both of them are like sort of complementary, so they cancel each other. One is computing the address, one is computing the value at that address. Okay, so these were the quiz questions. Now let's move on to the programming questions. Okay, so first question here is we have like write a C program to reverse a word using recursion. Okay, so input to the program is a string that is to be taken from the user, and output is reverse of the input's word, and you have to use recursion here. So for example, if your input is nptel online, then the reverse string will be like you have to print it in reverse. Okay, ONIL. I hope you understand, right? So if you so you have to do it via recursion. Without recursion, of course, it's very easy, but how will you do it with recursion? That's actually the question here.
I kind of forgot the concept of recursion. Can you please explain?
Explain, can you repeat question?
Recursion. I forgot the concept of recursion. Can you please explain?
Yeah, sure. Yeah, so Yeah, recursion simply means that when a function calls itself. Okay, like for example, you can write here, say, what should I write? Print something. Print values. Let's say this is your function, okay? And what you want to do in this function is that you will give it some input, say I, and you wanted to print values from I till 0. So you wanted to print all of the values. So one way to do that is to write a for loop, right? First, let us write that for loop, and then we will see how to do it by recursion. So print values from a given number till 0. Okay, so one way is to do that is for loop. So you can write for I is equal to, not I is fine, I is equal to capital A. Let's say A is your number and I is greater than equal to 0, I minus minus, and you can just say printf value of I. So this will print all the values of I from capital A till 0, right? Now you can also do this via recursion. And how will you do that? For that, you can write a function, say print values. You give it that integer value A, and what are you going to do here is that printf, I should write it %d A. That's what you want to do, right? You want to print the value of A. So once you have printed the value of A, let's say it was 10, now you want to print 9. For that, you want to call the function again. So call this function again, printf values A minus 1. So if it were initially 10 here, then you printed 10 here, then you called the same function with value 9. So then it will be again called with value here 9. It will now print 9. It will be again called till with value 8 and so on. So it will keep calling itself. But now with recursion, you need a base case. What is a base case? A base case means something that will terminate your, like in a conditional also, in a loop also, you had this condition which made your program, which made your loop to terminate, right? Or similarly in your here your recursion, you need a base case which will stop the function to be called again and again. So to break that recursion, so you will say, okay, if A is equal to 0, then return. I mean, you just want to print it once more time, maybe, but then maybe you can just say, okay, if A equal minus 1, then return. So now how will that work? I'll just show it once with a very small example.
Yeah, understood.
Okay, you understood? So still
Yeah.
okay. If value of A is 2, then initial value when you call it from function, say main, it is 2, then it will go here, check if condition A is equal to 1, it will not be true. So it goes ahead and print the value of A2. Then it calls itself the function is calling itself. That's why it is called recursion, okay? And it calls itself with value a minus 1, which is 1 now. And then it will go here. It will again, this will be false. It will print 1. Then it will call itself with value 0. This is still false. It will print 0. Then it will call itself with value 1. At which point this will become true and it will start returning. So when it returns, it will return here to the last call. Okay, it will return to the last call, and then afterwards they will also start returning. You should write here return. Okay, so is this recursion clear?
Yeah.
Okay, let's try the okay, then let's try this. So here we have to write a program to reverse a word using recursion. So like in the example I gave you, we just had one integer as an input. Now instead of that integer, we will have some string as an input to the recursive function, and then it needs to call itself again and again so as to reverse it. So it can create inside that recursive function, or maybe outside, you can take a global variable and you can call it, okay, reverse string. And in every recursion, you are going to, like, just think about it. How did the value of here, how were the values? Value initially of a was 2, then it became 1, then it became 0, and then minus 1. So if you have to, so while going inside, while calling the functions in from like first printf value, when it was called, it was 2, a value was 2, then 0, then minus 1. When the control will start returning back, so from here the base case will become false, it will return back. So when it starts returning back, these value will actually be in the reverse order, minus 1, 0, 1, 2.
So our function should have two parameters, the string and I know.
String and I. Yeah, you can take two parameters, or you can make one of them as global or static. Two parameters is also fine. If you want, yeah, it's fine. So with respect to this particular function here, if we were to store the values of a in reverse order, like from 0, here we printed them in order, like from 2, 1, 0. If we were to, let's say, store them in reverse 0, 1, 2, then how will you do? You will let it, like, so this is how your program will execute, right? First, this print function is called with value a equal to 2, which calls print values with a equal to 1, then which calls print values with a equal to 0, which calls it with a minus 1. So now when they start returning back, so when you return back here, you're going to say, okay, let me store this. So you'll store this value. Then when this returns back here, you say, okay, let me store this now. So recursion is actually a fit for such problems where you want to say reverse, because when you're calling the function like first time in recursion, you are going in one direction. When you're returning back, you are going in the opposite direction. Initially the flow from was a equal to 2 to a equal to 0. Coming back, it is opposite from 0 1 2 onwards, right? So similarly, if you have to do something similar for a string, no.
Yeah.
Okay. Did you understand why recursion will be good here to reverse?
Yeah.
Okay.
Yeah.
Okay, then do you have any approach in mind? We can.
And the condition will be I is equals to length of the string. If it is I is equals to length of the string, it will return. And I value initially will be 0.
Okay. Okay. Yeah.
I value initially will be 0.
Yeah.
And then the base condition is I is equals to length of the string,
Yeah.
then it will return.
Right. Okay.
And the printf will be percentage B A of I and then return reverse string.
Right. Okay. Okay. I understand. So you're saying that you will know what is the length of the string. So you are going to do something similar to here. Your base case will be when the I variable, which is initialized to 0, becomes equal to the length, then you will start tracing, like you'll stop your recursion there and traversing back. When you are traversing back, you are printing the value at that index, you're saying. So first the value at index, length minus 1 is printed, then length minus 2, then length minus 3, and so on till 0, right? So if we were to write that, here we can say something like print string in reverse. We're saying, okay, if I is equal to length, which you say no already is some global variable, then you are saying, okay, return. And otherwise you kept calling string this function with str and I plus plus. Initially it was called with 0 as your input, and your original string, say we'll take some very small string, say cat. Okay, that was your string and value 0. So here, and when you come back, you are here saying, okay, printf %c str I. So here, let's see.
Then the printf statement be before the calling of the function, because if you're calling the function, it's getting
Okay, so if it will be before, let's see if it is afterwards or before. I think, yeah, that's a question, an important one. But let's see whatever I have for now. Let's work this. Let's see if this works. Okay, for this input cat and 0. So I is equal to length. Length we know is 3. Okay, so it won't be true. Then we calling print string in reverse. String is cat I plus plus. I is now 1. Okay, here I is 1. It will be calling itself here. Then 1 is equal to length, which is 3 now. Then it goes here again. I is incremented to become 2. Then it will call itself. 2 is equal to 3 no. So then it will again call itself with 3. And here it is like, okay, 3 is equal to 3, then return. Then where will it return? It will return to the place from where it was called with value as 3. That is the last one. In the last one, I was 2 and I plus plus was 3. So I was 2, I is actually changed here. So this should actually be -1, not even I here. Or we can -1. Okay, so then here we are getting I -1. I -1 is 2. What is that? This is 0, 1 and 2. I -1 is 2. So string to value is t. So it will print here t. After that it will return. Now where will this return? This was called. This will return to the last call from where it was called. So it was called when I was 2. I was 2 from here. I'll make that stack here. Stack type thing. Okay. So function, I'm just going to call it P. And we're going to keep track of here. I'm not going to write anything in the function. I'm just going to write here what is the string. String is also, we know, just like I. I is initially 0. Then I will be 1. Then I will be 2. I is 3. When I become 3, then this return will be, then this condition will become true. So it will return. When it returns here, then we are printing the value of C at index I. So yeah, let me just change this a little bit here so that it will be easier. It is, let's call it I plus 1 and then it will be I. Okay. Then we are going to print here the value at I. So value at I we are going to print, which is T. So it will print T. Now when this has printf finishes, it will return here. So it will return here, then it will print. Return here means it will return at this function call here. So soon after that there is a print. So now it will print the value at I equal to 1, which is A. Then this call will also return again at this call location where it was called with value 1. After that it is printing the string value at 0. So it will print here C. And after that, whenever it is going to...
No, but it's not even going into the printf, because first it keeps returning to the calling, the function call. So it keeps going as a loop, no, because it's not even going into the printf. It keeps calling the function again and again, and the base value is each. But what will it return though? I didn't get it.
Okay, I'll explain again.
Everything under that will be returned, or only that will be returned?
Okay, this is like your program stack. Okay, you have here let me just write it. You have here void main, I mean your main function. Is this visible? Okay.
Yeah, it is.
So you have here your main function. Okay, the main is going to call this print function, print string reverse. Let's say I'm just writing it short form, and it is giving it a string, say cat here, and I is being given here as 0. Okay, this is what is being given. So here first on the stack main is called. Main then calls print a string reverse function, this str function, with these variables cat and I. Here I'm just going to keep track of I is equal to 0 initially. I'm not keeping track of cat because that is not changing. We're not changing the string anywhere in this. So I is 0 here. Now when I is 0, it comes here. Okay, then you are checking the length. You know the length. Let's say length is some global variable and you have already stored it here, that length is 3. You can compute it here and update it. Okay, so you're going to check I is equal to length. I is not equal to length, I is 0. So this condition is false. When this condition is false, you go to the next line here, which is print string in reverse. It's calling the function. It's calling itself. Now when it is calling itself, it is passing an argument as I plus 1. So here you are calling a function. So again, an entry on the stack here, I'm writing that it is calling itself with I is equal to 1. Okay. And then when it calls itself, then it goes here like this. Then I is equal to 1 here. Then 1 is equal to 3. 1 is equal to 3 is false. So it, in this particular call of function, which is this one, in this call of function, it is again calling another, it is again calling itself with other arguments. Now what is the argument? It is changing I to I plus 1, like 1 will become 2. So now the argument is I is equal to 2 here. Now when the argument here is I is equal to 2, it again comes in here, checks 2 equal to 3, no. So it again calls itself right here. So now I is equal to 3 is here. Now when it is called with I is equal to 3 here, it comes to this if condition. If condition will become true. When if condition becomes true, it returns. Now where does it return? It returns to its callee. And its callee was what? The function with the input argument is2. So it is not doing anything. It's just returning. So no print is happening here. It just returns here to this function call. Now this function call was here. So it returned here. The program, the function will continue once. So it called some function, that function returns. So it will continue with the rest of its statements, right? So it will return, when it returned here, it will go to the next statement, which is the print statement. In the print statement, it is saying, okay, print stri. Now I is 2. So string 2. So print the value which is at index 2, which is here in our case is t. So it here will print t. After that it returns. Now where does it return? It returns from the place it was called. It was called by the print string in reverse function call in the previous recursion call, right? So which was when I is equal to 1 here. So it will return here. when I was 1. So when again in that, again there, it's returned here, it will go and print string value at index I, which is 1. So it will print here A. This, are you able to follow this?
Yeah, yeah.
Then when I is equal to 1, this will also finish with return. So now this will return to the first print string in reverse recursive call where I was 1. Sorry, I was 0. So it will return here, basically returns here, but then it continues executing the next statement, which is the printf string value at 0. So value at 0 is what? C. So it will print that and then it returns. Now where does this return now? It returns to main. Here. Basically here. It will return here. And after that you might have some more statements in main we want to do. So maybe those will be executed here. And this this is actually the stack, program stack. So program, when it executes, it keeps track of like function calls with this data structure called stack. So whenever a function is called, that function entry is pushed on the stack. Like main was called first, main started, so its entry was there. Then main called print string in reverse, then an entry for that was made. Then print string in reverse called another print string in reverse, then that was made an entry on the stack, and so on. So this stack data structure keeps track of this calling sequence, and when any function starts returning, it returns back to its caller, right, from where it was called. And so here it is important to keep this printf statement after the call to the function in order to print these in reverse. If you put this in before this, then you are printing while you are calling the functions. So while you are calling the functions, then you will print first C, then A, then T, and not in reverse. Do you understand that difference?
Yeah, got it.
Okay.
Yeah.
Okay, so here, but here we have actually printed this. So if you want to store this in a reverse, like in some string, then you can, instead of this printf statement, you can actually have here you can create one reverse, like you can create here a array of characters.
The string and give the value, assign values.
Yeah, you can. Yeah, you can just write here rvi is equal to str. Sorry, you will have to use some other parameter here, j. J will start from 0 and you have to increment it every time. So you'll have to do that a bit carefully, right? J will initially be 0 and you'll have to increment that every time. But you get the idea, right?
Yeah.
Okay. So this was one way of doing this, which you suggested. And then I have another solution as well. Here, let us look at this program from the beginning. We have the library stdio, which we have included. Then we have defined max macro, which is as value 100. So which here it is indicating the maximum size of the string. Then we have a reverse function, which is taking as input a character array, returning a pointer to a character, and in teach. Then we have main. In main, we are first scanning the string that we want, input string which we want to reverse, and then we are calling this reverse function with the input as the str string, and this will give us back, this reverse function is giving us back a pointer to a character, that is the pointer to the reversed string. Okay, and then you are here there printing the reverse string. Now what is, now looking at the body of the reverse function, here the reverse function, first we have these two static variables, static int I equal to 0 and static character reb of max. Like it is a array of characters and the size is max, and these two variables are made as static, means these variables are local to this they are local to this reverse function, but they will be initialized only once. So even when you call reverse again and again, I is initialized to 0 only when it is called the first time. If it is changed to some other value in any function call, say to value 2, then it will remain so until it is changed. So static means it is not going to be initialized. If you did not have the static keyword, then whenever reverse is called, then another local variable will be created, initialized to 0. But static means that it will not be, if there is only one variable for all the calls of reverse functions, and that variable is not initialized again and again. Okay, that's what it means, which is important here. Then here it is saying, okay, if value of str, so str you have passed it here, what is str, you passed here str, so str, what is it, it's a pointer to a character, right? It's a pointer to a character, so basically it is the pointer to the first character in that array of characters, right? Like if the string is cat, then str is the pointer to character c. So it is saying if value at str is not 0, like if it is checking that it is some value, non-zero value, then you do this. So initially the str is pointing to say index 0, so say c, so it is not null. So after that, if str, that if value at str, then you go inside. Here you are calling itself. So if you will see, if you'll observe, it is actually similar to what we have written, but a bit different, but different. Like there you were using if condition to check the length. Here also it is in some sense it is using the if condition to check the length, but in a different manner. There you were using computing the, you're using that index to check that it is not equal to length. It is just here checking. So in character string, you will know that first it will be C, then A, then T, and then there'll be null character, right? Here it is just checking it until it hits this null. It is initially at C, then it will be incremented to A, then it will be incremented to T, then C. So it is also checking along the length as we did in that on the whiteboard, but just a different way of it's just a slightly different way of implementation.
Yeah, got it.
Yeah, and then there also we called the reverse function first, right? Here it is also calling that reverse function. There we passed the I variable after incrementing it, like +1. Here it also is incrementing that pointer. Initially, if it was pointing to C, it's now saying, okay, let's now point it to A, the next character, and so on, right? Until it will hit the null character, at which time it will start returning. When it starts returning, here you are saying, okay, store that value which is at this index into the reverse string. So it is essentially the same, but right, did you understand this implementation?
Yeah.
Yeah, so it is essentially the same. It's just using here pointers, while in that we have used the index variable to do the checking and to do the copy. Okay. Okay, let's move on. So we have this next programming question here is write a C program to check whether a given number is prime or not using recursion. So are you familiar with prime numbers?
Can you hear me?
Um, yeah, I was saying, are you familiar with prime numbers?
Yeah.
Okay, what can you tell me?
So basically, it's only divisible by 1 and itself
Right, right. That's
the
absolutely
prime number.
yeah. So programmatically now you have to check a given number is prime or not. Using recursion, it's saying. So how will you do that? Like first you can tell me how you will do it. Let's say with a loop, and then we can
Two
discuss.
for loops can be used.
Yeah. So
No, one is enough. Huh?
one is enough. Yeah, I
I
think.
think one is enough, right?
Yeah. But how will you do that?
For I is equals to 1, and then I must be greater than the number, greater than or equals to the number,
Hmm.
and then I plus plus.
Hmm.
If if number divided by I,
Yeah.
percentage reminder divided
Yeah.
by I equals to 0, it's not well, it is
Yeah, that's correct. So you are going to check for all the numbers which are from 2 to less than that number, and you're going to check if any number divides it completely. So for that you're using the modulo operator percentage. So you're going to say, okay, if the number, let's say, is n percent I equal to 0, then it is not prime. And if you finish the for loop without finding any such number, then you can say, okay, the number is prime. So that was correct, a way of doing it with a for loop. Now how to do this using recursion?
so we'll be incrementing the I value and checking the condition of percentage. N percentage I equals to 0.
Right, that's
Right.
correct, I think. So if you will be,
So the base.
yeah, go ahead.
I is equals to n return.
Yeah, that's correct. Yeah, we can start from I equal to 2.
And then
Yeah. Yeah, were you saying something?
I think so I muted myself.
Okay. Yeah, that's correct. I think you are on right path. So your approach seems to be correct. So we can just look at the function body here. Check prime. So here number is the and num is the number which we want to check is prime or not. I is the index, as you are saying, not the index, but I is the number for which we are going to check its divisibility with. And here we are. This is actually in reverse. What you were saying was from 2 to the number, like incrementing every time. It is doing it in reverse, like decrementing. Both are same. Yeah.
That's same.
Right. So here the base case is I is equal to 1. If I becomes equal to 1, then you can return 1. Here 1 value in return means it is prime. Okay. So means prime, and else you're going to check, okay, if number percentage I equal to 0, then you will return 0, non-prime. And if it is not divisible by I, then you are going to return, like basically you're going to check for next value of I, which is I minus 1. So you're going to here call check prime with I minus 1. So this will, let's say it starts from number minus 1. I is num minus 1 initially, so it will check with num minus 1 here. If it is true, then it can return 0. Otherwise, it will check here with num minus 2, then num minus 3, and so on till 1. If it doesn't find anything which divides it by 0, divides it completely, and in the end I becomes 1, then it can return that it is prime. Here, when you're calling check prime, actually you're using here num divided by 2 and not num minus 1, because any number which is greater than num divided by 2 will not be able to completely divide it, the number. So it's like only the half of that number or below that number, half or below numbers can like divide it completely. So that's why it is using here num divided by 2. But irrespective of that, it is just going to change the time complexity of the program. Even if you use num minus 1 here, that is actually still going to give you the correct answer. So okay, so did you understand this recursive function?
Yeah.
Okay.
Where to get the recordings?
Okay, the recordings, yeah, they are on a YouTube channel. I can share the link with you for that after this. Okay. Okay, so then you have one more. We
Okay.
have okay, so we have this one more like last programming question for today, which is you have to write a C code to check if a 3 by 3 matrix is invertible or not. A matrix is not invertible if its determinant is 0. So are you familiar with the what is a matrix? What is a determinant of a matrix? And
Yeah.
okay. Okay, then do you know the formula to compute the okay, so first question is how
Yeah.
okay, so first question is how do you represent a matrix in a C program?
In 2-dimensional array.
Right, that's correct. So you will read a 2D array. I mean, that is an easier representation. Yeah, so you can use a 2D array for this 3 cross 3 matrix. Then to compute the determinant, if you know I'll just write it for the sake of completeness. You already know it, but just still I'll write it here. So if this is your matrix A00, sorry, A00, A01, A02, where the first index here is the row number, second is the column number. Okay, so this is 0th row, 0th column, then A10, A11, A12, which means now first row and 0th column, first row, first column, and so on. Then A20, A21, A22. Now this is your matrix, 3 cross 3 matrix. Now to compute the determinant of this matrix, the formula is that the determinant is equal to A00 times A11, A22 minus A12 times A21. minus A01 times A10, A22 minus A20, A12 plus A02 times A10, A21 minus A11, A20. So this is your 3 cross 3 matrix and this is the determinant. Now the question is just simply asking that if you are given a matrix of 3 cross, if you're given a 3 cross 3 matrix, then you have to tell whether the matrix is invertible or not. Now a matrix is invertible means you have to compute the inverse of this matrix. If you represent A is, if this is A, then you have to compute the, so inverse means A inverse, okay, A minus 1. So here in matrices, a matrix is invertible only if the determinant of that matrix is not 0. So to say whether the given matrix is invertible or not, all you have to do is compute the determinant of that matrix, and if it is 0, then you can say it is not invertible. If it is non-zero, you can say it is invertible. So in your program, all you have to do is read the matrix, compute the determinant using this formula that we just saw here on the whiteboard, and if it is 0, then you can say not invertible. If it is non-zero, you can say invertible. So how will I do that?
We have to write the formula. We're going to use programming things for the formula.
Can you come again?
And we just going to write the formula, like the function. We're going to do it. It's substituting values.
Not clear to me. Like what are you saying?
In the okay, this thing. It's not a program.
Sorry, but I can't understand properly. What are you saying?
I'm asking if we are we going to write the formula of the determinant in the program, like manually write formula. We're going to write the formula manually in the programming, like B equals to A naught into A1 0. Are we going to write that in the program by first manually, or are we going to do something for that, like using a for loop or something?
Right. So you're saying that we don't need any loops or anything. We just need to write the formula in the program and that will be enough, right?
I'm asking if that's how we're doing this. That's the easiest way.
Yeah, that is that's it. Like you don't need anything else, because why would you? Because if you would have needed that for loop or something, if the program had said okay, n cross n matrix, like if you were say if the program said okay, the matrix can be of any arbitrary size like n cross n, sometimes the matrix is 4 cross 4, sometimes it's 5 cross 4, sometimes it's 100 cross 100, then you would need to write the program in a generic manner, right, which will work for any size of matrix.
Yeah.
Then you would need those nested for loops. But here the program itself is saying that it is a 3 cross 3 matrix. So you don't need a generic program here. Here the input itself is not going to tell you the size of the matrix. It's just those values of the matrix. They're like 9 numbers here. So that's why the easiest and way to like program this particular question is just write that formula, whatever we just saw, programmatically, right? But yes, you're right. If you have to write it for some generic matrix with some arbitrary dimensions, then you have to use for loops. So then coming here, first of all, you are going to, your A is your array, 2D array of size 3 by 3, okay? And then I and j are some integers. Then long, you're using a determinant. Long is another data type, okay, which is has more, which can store long, like more, like higher values than integer. It's usually, I think long is like 8 bytes while integer is 4 bytes. Then you are reading the value of matrix, okay? So here you are saying, okay, aij, so read that value from as input and place it in the address, in this address, which is aij. So using that, then if you are computing the determinant, you are using that formula itself which we just saw, and now you're just using, okay, this indexes to index into the matrix 0 0 1 1 etc, and that formula is just written here. And if the determinant is 0, then you can say, okay, matrix is not invertible, else you say matrix is invertible. So any questions?
No.
Okay, is there any question from any so whatever we discussed today, do you have any doubts in any of the questions we've discussed so far?
No, but I was expecting you saw the questions on trapezoidal rule and rule Puttha method. Is that not important?
Come again.
I was hoping you'd solve the questions on trapezoidal rule and rule Puttha method, which was 2011.
Okay, then I
Our
can
emergency.
sure. I was not sure if that is part of the syllabus, but is it part of the syllabus?
Yeah, in week 11, we learned trapezoidal rule and rule Puttha method. So, is it not part of the syllabus then?
No, I'm not sure. So it must be. So I can, yeah, I can do that next week.
Okay.
Yeah.
Yeah.
Okay. So you have done, have you solved the programming have you solved the assignment related to that?
Yeah, I did.
Okay. Okay.
But those programming, uh,
I can't hear you. Yeah, sorry, but I can't hear you. I don't know why. Okay, I'll stop the recording. Thank you for joining.